All right, so I did get a few questions this morning, and I'll start answering them. The first comes about, both these are from Organic 1. The first one comes about from a question about the discussion board for last week. So the discussion board last week, you start with trans 2-butene, and you want to form, form the alkyne, and then you want to form the diene. And ask you how to do this. And another question they asked regarding this question is about the individual mechanistic steps. So my recommendation for this, there are lots of ways to do this, but I think this is the easiest way to do it, is you're going to start out with bromination of the alkene to give you this this dibromo complex. The next step here is to react it with, and this is something I've said mistakenly, there's actually two steps to this, the NaNH2 and the NH3. And what's going to happen in this case is that we have hydrogens. So this N2 minus, which is a product of the sodium reacting off a hydrogen, going to attack the hydrogen, knock down the bond, dislocate the bromine, and this is going to happen twice to give us, ideally, this compound here. So, I shouldn't say ideally, that's what it is going to give us, is this compound here. Now, ideally what we would follow this with is an acid workup. So, the notes talk about adding H2O. In this case, we don't really need the H2O, and I'll talk about when we get to the terminal alkynes why we need the H2O. But this is how you get to the first one, which is 2-butene. Now, the second step is actually just like the first step. You're going to first add bromine. And what will happen with the bromine is that you'll get this tetrabromo complex. And then the next step here is to add the NH2 and the NH3. Now, it's going to do the similar thing, but instead of, because there's no hydrogens on these central carbons, we're going to get the hydrogens abstracted from the terminal methyl groups. So at first, we will get this compound. So we'll get the double elimination on both sides. And unfortunately, I'm going to write this over here, but we're going to get this compound first. And then what's going to happen is that we have hydrogens on the end of each of this molecule. And this is acidic, this is basic enough, this NH2 anion, to extract the hydrogen off the end. So really what we finish with when we do the NaNH2 is hydrogen missing off both sides, and we end up basically creating a double anion. So the student asks, what's the mechanism of water? Well, we're going to need to add the water in this case because we have terminal hydrogens removed. And what will happen is that when we add the water, the lone pairs that are generated by abstracting the hydrogen off the end are going to abstract the hydrogen from the water, and we're going to end up getting this compound here. So basically, the water serves as the hydrogen source. If we have a terminal alkyne and we do the NaNH2, NH3, we're going to end up extracting the hydrogen off of the alkyne. And so we just had to add water back to put the hydrogen back on it to ensure that we actually get the neutral compound. Now, I haven't been taking off for this because honestly, I just totally forgot that you need to have it in there. You don't really need it at this step because you don't have a terminal alkyne. You have a centralized alkyne. So there's no terminal hydrogen to abstract. But definitely with the last stop, if you're being proper about it, you do need to add the H2O. All right. Also gotten a couple homework questions. So let me bring up the homework. And again, this is for Organic 1. Question 29. Hey, you're welcome. And actually, I just saw this. If you look at the first homework problem, it goes through this as well about how the terminal hydrogens will abstract the water as well. All right, so the following reaction has been described in the chemical literature and proceeds in good yield. The reactants may be more complicated than those you have encountered so far. Nevertheless, on the basis of what you have learned already, you should be able to predict the principal product in each case. Draw the product for the following reaction. So the reaction is and we have tert butoxide, and we're going to do an elimination. So I see a couple possibilities with this. But first rule is we've got Zaitsev's rule. We have to abstract off the first one at the most substituted carbon. So our tert butoxide here is going to attack the hydrogen. This should give us a double bond. And as a first pass, we should get this compound. Now, in principle, we could abstract a second hydrogen and get rid of that chlorine. But this is what create what's called accumulated alkene. So if we removed the hydrogen from here and the chlorine from there, we could get this compound, but this is a highly unstable compound. So my guess here is that you're not actually forming that, you're only doing the single elimination product. So let me bring it up. So my guess is that this is just the single elimination product. Because this compound itself is going to be highly strained anyway. So if we eliminate both, it says there's no chlorines in the final product. This would be my second guess, is that we're going to eliminate now from the adjacent carbon. And so third guess here is that you're going to drive the formation of an alkyne. Okay, so a little bit of a tricky problem. I'm guessing a lot of this is steric hindrance. Your ability to, you are right if your assumption is with Zaitsev's rule, you should be eliminating off of this one preferentially. I would agree with you. I think what's driving this reaction in this case is steric strain. This has to be a 60-degree bond when this is done. That's going to be horribly strained in terms of an alkene, which prefers 120 degrees. So I think in this case, you don't get elimination from that hydrogen simply because of steric. You don't get elimination of that hydrogen because of steric strain. What you end up getting is elimination from the methyl group. And you're going to do this twice to give you the terminal alkyne. But if your first assumption was, well, shouldn't it go between that carbon and that carbon? I would agree with you for a given, for just the general case. But in this case, you've got that really tightly constrained ring, so it's not going to really favor the formation of an alkene. All right. Other question is 51. So predict the principal organic product of the following reaction. Specify stereochemistry and show all bonds. Okay. So this is Michelson ether synthesis. Big tip off that this is Michelson ether synthesis. You've got that big iodine sitting in the molecule, so it starts you out with this. And it also starts you out with an alkoxide. So that Na there is just produced when you react sodium with an alcohol. This is really what you have. So you're going to get nucleophilic attack on that carbon to displace the iodine. Now you sit back and say, well, how do you know that this isn't producing an alkene? One, this is a primary alcohol, so as a primary alcohol, it's not sterically limited. Two, iodine's a really good leaving group. It's actually better than bromine and chlorine for leaving, so you will probably get some elimination products, but generally speaking, because your iodine is your leaving group and you have this primary alkoxide, most likely you're going to be doing elimination or substitution. Now we don't get a stereochemistry change when we do Williamson ether synthesis. So our product here is 1, 2, 3. This is the R ether. So let me draw it out. There you go. So the biggest potential pitfalls I see with this problem, or could potentially see with this problem, one, not drawing the stereochemistry, and two, it is an ethyl group you're reacting. So there's a temptation just to kind of leave it as a methyl group, but it is an ethyl group that's there. All right, so that's it for the questions I had. Are there any questions from anyone who's watching right now? All right, so just a reminder, today is the last day to resubmit your discussion boards for regrading. I gave you the whole semester work on them, but we are kind of getting to the point of the semester where I need to submit grades pretty shortly, so this is why I put the cutoff as Tuesday at midnight. So tomorrow morning, when I get up and start doing grading, I'm going to grade all the discussion boards that have been submitted to that point. If you submit any discussion board after tonight at midnight, or after I grade them tomorrow morning, you're just going to get a statement saying it's too late to submit them. So we're kind of finishing up. The homework's due tonight. The discussion boards are due tonight. The labs are finished up. You've done the exams. There's no more quizzes. There's no more homework. At this point, the only thing you have left in the course for a grade is the actual final exam. So if you're curious what it takes to actually get the grade you want in the course, as of tomorrow, I would say about 10, 11 o'clock in the morning, I'll probably be done with all the grading. Let's say your G is your grade in the course. Take your grade, multiply by 0.78. And we'll say D here is the desired grade. Divide by 0.22. And that'll be the final exam grade. So if you want an A in the course, D here is a 90. If you want a B, it's going to be 80. If you want a C, it's a 70. If you want a D, for whatever reason, it's a 60. F, obviously, is a 0. But take your grade, multiply it by 0.78. Subtract that from the grade you want to get in the course, the absolute minimum grade, and divide by 0.22. Now, this is not a guarantee. This is a nice back of the envelope calculation. There's like a half-point error in this because of assumptions I'm making. But if you are curious, like, well, I need a B in the course, well, take 80 minus your grade in Blackboard times 0.78 and divide by 0.22. That'll tell you what you need on the final exam. You cannot do better than 100 on the exam. So if it's telling you like you need 101, you're not getting that grade. It's impossible. Hold on. We've switched to multi-factor authentication, and now it's trying to throw me out of certain programs. So I need to get my phone so I can do the authentication key. that should fix that problem. I think that's it really for technical aspects concerning the rest of this course. Exams, 30 questions, both for Chem 1 and Orgo 1 and for Orgo 2. Go look in the syllabus, it'll give you 30 questions. Also, a reminder that this Thursday at 1 o'clock, we also have a live stream. The link has been sent out for that. That was requested by a group of students in Orgo 1. They get priority on the questions, so if they're asking me questions, I'm going to take priority over other questions. That said, it's open to anyone who wants to show up. So if you have questions, you're free to come ask them. That's kind of your hour to use. It'll be posted to the live streams just like everything else, so you can see it if you can't make it. Other thing, technical issues with the exam. The exam opens up tomorrow morning at 12:01 a.m. If you are having technical issues, you need to email me as soon as possible. The last day of exams is Tuesday, and at 5 o'clock the school is officially closed. That is the end of the semester. You cannot submit anything beyond 5 p.m. without doing an incomplete. Incompletes have to be justified by the instructor. It's really hard to justify you taking incomplete in the course when you had 7 days to take the exam. So what I'm going to say is practically by Monday, take the exam. So if you have technical issues Monday, you've still got Tuesday to take it. But if Tuesday you're sending me an email at 3 o'clock saying, hey, I'm having technical issues, that's you. You should not have waited until the absolute last minute to take the exam. Also keep in mind with the exam, like all the other exams, it's not going to let you start the exam if you have, let's say I give you, you're going to get, all students get an hour and 50 minutes to take this exam. So if you start the exam at 3:30 on Tuesday, it's going to say that you don't have an hour and 50 minutes left to take this exam, and it's going to lock you out. Again, that's a technical issue. You should not have waited so long to take the exam. So don't assume you're taking it soon Tuesday. Assume that you're taking it sooner than that. If you have technical issues and you email me before that Tuesday deadline, I'll have time to go through and diagnose what's going on. But definitely if you sit back and say, hey, I was planning on taking it, really late into the semester and, it didn't quite work out, I was like, there's really not much I can do for you, because to justify an incomplete, there has to be justification. You as a student have to demonstrate you could not take the final. That's really hard to do with the 7-day exam window. Most incomplete requests, when we talk about incompletes, we're talking about people who are deployed for active service, people who are hospitalized. You really have to document what's going on. So do make sure you take that exam early. Also, the earlier you take it, if you want to argue for a grade change, that's something else that I'm not going to entertain on a Tuesday, because Tuesday all my grades have to be submitted at 5 o'clock. So if Tuesday you're going, well, is there anything I can do to make up the points? The answer is going to be no, because I need to get my reports in. So if you take it like Thursday or Friday of this week, you say, hey, wasn't quite the grade I was hoping for. Is there anything I can do? We might be able to find something worth regrading. But definitely Monday, if you're emailing, say, hey, I didn't quite get the grade I want, is there anything I can do? The answer is, I have to file a whole bunch of paperwork Tuesday. I'm not going to have time to look over anything that you submit for a regrade. But that's the typical final exam stuff. Like, start it early. That's going to be the best option for you. But you are given this large exam window, with the idea being that I know a lot of people are offering their exams basically Wednesday and Thursday. If you need time to study or you need time to recover, you've got the whole weekend. But again, take it earlier rather than later. Okay, if there are any questions, I'm here if you need anything. Oh, looks like I have a real question there. Go over the discussion board for making and naming ethers. Yes. This is actually this is for organic one. This is actually a surprisingly easy discussion board, as long as you don't try to overthink it. So in this case, you're going to make 3 ethers. And the 3 ethers here are, 2 of them are really obvious. So to have an ether, you need 2 alcohols. So we have ROH and some other ROH forming together, removing their water to give you this ROR prime. So in this case, we have a couple of options. R can be the ethyl group, and R prime can be the ethyl group. We can have R as the propyl group, and R prime as the propyl group, or we can have R as the ethyl and R prime as the propyl. So basically, we generate 3 ethers. We generate two symmetric ethers. So we have the diethyl and the dipropyl, and we can also generate the asymmetric ether, which is the ethyl propyl. So for the discussion board, we can do the diethyl, dipropyl, or the ethyl propyl ethers. Now you can also do this by the alkoxide naming, so you can do ethoxy ethyl ether, propoxy propane, or I'm sorry, ethoxy ethane, propoxy propane, and then ethoxy propane. I would probably just stick with these because they're a lot easier to work with. We rarely work with a functional group naming version of the ethers. Ethers synthetically are very boring. They don't really react with much. They're pretty stable. So we did also, you can kind of see from this, it's hard to do anything other than a symmetric ether. Otherwise, you're going to get a mixture. But yeah, that's the discussion board. You form diethyl, dipropyl, and ethyl propyl ethers. You're welcome. Yeah, if you're worried that this week's discussion board was really easy, it's meant to be. You only have 2 days to do it, and it's really just kind of there to like kind of round out the semester. So yeah, if you looked at the organic 1 and even the organic 2 discussion boards this week and went, wow, that's really pretty underwhelming, it is. It's kind of a break before you do your finals. questions. So I was waiting for you now. I'm studying Old Testament notes and test packets working on one. Any recommendation on studying for the final? Honestly, I don't really have, that's really what I would do is I would look through the old exams, so it'll give you a feel for the types of questions that'll get asked, particularly exam 1, 2, 3, 4. The ether stuff and the alkyne stuff is going to be pretty similar to what you're seeing with the discussion boards and the homeworks as well. So the homeworks and the old exams are good to study by, and also the discussion board, those packets that are online are much harder than anything you're going to see on the final exam. So if you're kind of like knocking it out of the park with those packets, you're going to be fine on the final exam. Optical activity problems. So we can go back to the ones on the discussion packets. All right, let me open them up. And it's going to take a minute for this computer to open up the Word document I'm getting at, so give me just a minute. Oh my goodness, this computer is slow. So your optical activity formula, the measured optical activity is the reference times the path length times the concentration times the EE over 100, where the EE here is 100 is in percentages, so like 90% divided by 100 give you the 0.9. If you do the EE is what it really is, which is like 0.9, that works. And then just making sure, because I had to change this in the slides, concentration is in units of concentration here should be in grams per milliliter, and L is going to be in decimeters. Yep. So now to find some EE problems. So if you go to the test one packets, most likely what you're going to see are problems like this first column or like problem A. So for, well, actually the first one's really super easy. So for a racemic mixture of alpha glucose of 0.119 grams of alpha glucose dissolved in 100 milliliters of water, put in polarimeter with path length of 2.0, what is the observed optical rotation? So off the bat, you should know that's 0, because racemic mixture is an equal mixture of both alpha and beta form. Both is a racemic mixture of both the D and L forms. So off the bat, the first one's meant to be kind of really easy to make sure you're paying attention. But let's say you receive a sample of camphor from a manufacturer claiming to be naturally pure, and you dissolve 1 gram of camphor in 10 ml of water. It measures optical optimity in a polarimeter with a path length of 2 centimeters. From your results, you see the optical activity be 7.08. Is the substance actually pure? If not, what is the EE? And I think the 2 centimeters here is actually supposed to be the 2 decimeters, but we'll work it out. So you get 1 gram of camphor. And it's 10 mLs of water. And I'm pretty sure the 2 here is supposed to be 2 decimeters. And it asks you, is it pure and is it not pure? Oh, and alpha in this case is 7.08 degrees. So it tells you the optical activity was 7.08. And he wants to know, is it actually optimic pure? So camphor here has an alpha D 44.26. So if we stick everything into the formula, we have alpha as 7.08, alpha D as 44.26. Maybe that is supposed to be centimeters. .2 path length. The concentration is 1 gram divided by 10 mLs. And we want to figure out what the EE is. So if I start working this out, and unfortunately I got to do this in Excel, it's going to take it about a minute to open up because this laptop's slow. So I have 7.08 equals 44.26 times 0.2 divided by 10 by 100. No, it's supposed to be 2 decimeters. I was right. So it's a 2 decimeter path length, and again, I'm sorry, I switched stuff around at some point between decimeters and centimeters. So I get 7.08 equals 0.08852 times the EE. So the EE in this case is roughly 80%. Or it's going to be 80 because the EE here we're treating the percent as if it's a full number. So that's really the extent of what you would be doing for any type of polarimetry problem. Finding an antimeric purity or probably finding alpha here. You're not going to see something where you're trying to find alpha D or the length or the amount you dissolved or the volume that you dissolved it in. Very much the only variables you're really going to have to chase for this exam is the measured optical activity and the enantiomeric purity. So in the test one packet, it's going to be anything where the alpha row is blocked out, or it's asking you to find alpha, or asking you to find EE. But that's as hard as it's going to be for the final. Hello, how are you? Optical activity is very much a plug and chug formula kind of problem. So you feel like you really didn't do much conceptually with it, it's because you didn't. It's also hard to generate these types of problems. I'd prefer to give you real numbers. Most chiral compounds, it's hard to find their optical activity online. So I could make something up, which, I mean, granted, there's nothing wrong. You would know I was wrong. But for me, I just would feel more comfortable giving you real numbers, but that really limits them what I can actually assess you on. But yeah, optical activity is just hard to embed into the later material. Because things like alkenes they don't really have optical activity. Let's see how the enrollment numbers are looking while I'm here. Some rough enrollment numbers for this fall. Well, here's hoping they fill up. not really seeing much activity out there. So again, we have one last live stream. That is this Thursday at 1 o'clock. That was organized by several students in my Organic 1 section. So if you have questions, email them in advance, but they will be given priority in terms of answering questions. Other than that, I will see. Actually, I won't be seeing any of you again. This is kind of the end of the semester. So, all right, thanks for showing up.